Hey there, I'm Samantha, and I'm with Bree 3D. I'm here in our Austin factory today. I know my background frequently changes. And this episode of our meeting for the Fused Granular Fabrication Group is being recorded right now. We're gonna go ahead and put it up on YouTube at the end for anyone that wants to view this later or share it. And today we're in for a real treat. Shamelessly, the last couple of months when we've met up by request, we've shared some of Re3D's work working with containerized systems with the GigaLab in Puerto Rico and in the US. But the intent of this gathering is for ninjas and enthusiasts and pioneers and just fans of fused granular fabrication, or FGF, or some people call it pellet printing, is to provide a platform for us globally to get together because FGF printing is rather new and it's not easy, and so it's really fun to get to laugh and cry and celebrate the journey as we're all figuring this thing out. With that in mind, we love highlighting others in the field, not just Gigabot users or Re3D teammates, but today we have a real treat because we have David Schulz with us, and he is a technical sales associate with Massive Dimension. And he'll be sharing more about that. So he's hunkered down at home during a snowstorm in Vermont. But he's going to highlight the work going on with the Massive Dimension team, which is co-located with Philibot and has inspired so many of us over the years. David has a BA in history from St. Michael's College, and it's kind of fun too. It looks like he has a background in viticulture as well, which maybe we'll
Yes.
get some time to talk about later. But he has a deep domain expertise in sales, which is really needed, especially in our industry and industrial systems. And is also a maker at heart, and recently has worked on some really cool projects that he's going to be highlighting, particularly in the furniture space, as we're all thinking about, functional prints and where fused granular fabrication can take us. So with that in mind, I'm going to go ahead and turn it over to David, and I'm really stoked to learn more about him and the Massive Dimension team today.
Amazing. Thank you so much. As Samantha said, I'm David Schulz. I'm coming to you from the shores of Lake Champlain. I am in northern Vermont myself right now. Our team is sort of spread out, but most of the time we're centered in beautiful Barrie, Vermont, right outside of the capital. And as Samantha said, we are co-located with our sister company, Philibot. Some of you may or may not be familiar with that, but that side of our business is about filament production, plastic recycling, as well as diverting a lot of the waste from support materials and things like that back into reusable feedstocks for both filament printers as well as FGF, which is great for folks in the FGF or pellet space as we talk about our other side of our business, Massive Dimension. So I'm going to just kind of jump into it. Quick overview, who I am, who we are at Massive Dimension, some of the really cool things that we did in October. We just came off a campaign talking about practical utilization of FGF in terms of lighting, seating, as well as some other fun furniture projects. And then we're going to talk a little bit about the tech behind the prints and what we found some really great ways to utilize both hardware and software to get usable, practical applications for FGF prints. So as Samantha said, I am a technical sales associate here at Massive Dimension. I've been here for coming up on a year with before that, a brief stint running a Vermont-based beverage wholesaler. And then before that, I was an account manager for OnLogic, which is an industrial PC manufacturer here in Vermont. I have a background in both history, specifically medieval history, as well as I'm just a few credits shy of finishing my viticulture and enology degree from the University of Missouri. So there's a little bit of sustainability, there's a little bit of history, there's a little bit of science, there's a little bit of industrial automation, technology, and everything I do, which is great. And it's really lended itself for me to be successful here at Massive Dimension and talking to folks about FGF, pellet printing, plastic extrusion, all the day long. Who we are at Massive Dimension. The Massive Dimension side of our business was founded in 2018. We have deployed over 200 pellet-based extruders globally, but we are proud to be US-based, designed, and built. All of our contract manufacturing, all of our design, all of our prototyping, all of our engineering lives here in the US, which is we're really proud of. And then the opposite side of that is that we have these global robotic partnerships. So we are partnered with ABB, UR, KUKA, Fanuc, and Stably. Those are the folks that we have in terms of robotic FGF printing for partnerships. We have integrated on even more robots beyond that, but these are the folks we have formalized relationships with. And then in addition, we've done all sorts of crazy movement systems, from homemade gantries to retrofitting CNCs to folks who have done large format gantries that were cranes once upon a time, and all sorts of different things. So it's very cool to see how folks are applying our extruders out in the real world. One of the partnerships we're really proud of is our partnership with Dr. David Florian. I'm sure you guys have heard of him from Vanderbilt. Great videos. If you haven't, he talks about production and manufacturing and additive space in general, but he does a lot of stuff that we partner with in terms of both our Philibot side, but also he talked about constructing a large format pellet-based printer from the ground up using both our MDPH2 and our MDPE10, which was a great project for us to be involved in. So diving right into it, I'll step back one thing. One of my passions personally is furniture and furniture restoration. I have a mid-century leaning in my personal style, as you can kind of see in some of how I've pushed some of our stuff. But really the goal behind what we did here was we wanted to talk about what are the practical applications of FGF printing? What are some of the practical applications that you can see that is really easy to relate to for basically everybody. Everybody uses lighting. Everybody uses furniture. How is what I do every day something that I can tell my family about and they can understand? So when I talk about tooling and molds and things like that, they don't always get it. But furniture, everybody gets. So it was a great way for me to put together my passion for furniture and for mid-century design, as well as what I do at work on a daily basis, which is talking about 3D printing and plastics. So we started with lighting. There's two here. The first one here on the right, the smaller one, is a desk lamp, which was really cool. That sort of started as my office at the office was dark until I got one with a window. So I wanted some lights, some non-overhead lights. So we figured this out. We designed it in our slicing software, which I'll talk a little bit more about. And then we printed it using some of our robotic-based printers, which is really cool. Cool part about this is, this was one of the things where I was able to talk about what Philibot does, as well as what Massive Dimension does. The base of this lamp here on the right is made from walnut dust infused pellets, which is really cool. The Philibot line allows us to use, standard based polymers and create custom blends for our users, for ourselves. So we were able to do that with this. And then the top is just PLA. We were able to put this all together, and there's two of them. There's one here in my house, but there's one that routinely makes its way around the office, and I believe it's currently in our owner's office. But we always, particularly as the days grow short here in Vermont, we're always fighting for lighting. And then the second one here, the hanging one, was sort of an impromptu hanging shade that we made for a customer visit into our offices. They were coming to see our systems in action. And they wanted to see, so we made something that would work for them, something that would be along the lines of what they created. We were able to do a lot of this electronic integration here very easily. There's lighting kits. It's great. But it really starts to talk about, okay, one of the things that we talk about is post-processing. And post-processing can be finishing, but it's also integration with other components. Both of these lamps experience post-processing. The final hanging lamp, the goal for this was that it was going to get a wood base where the socket fit in that sit on the top. and final post-processing will be managed by the customer on this one. But this is PETG, so we've talked about doing some vapor or some heat treatment to change the way that those layer lines work and really create a smooth finish. That's one of the things that folks liked, but they also ended up really liking the FGF lines, those lines that showed up for the production and showed off that, hey, yeah, this really is 3D printed. Look, this is a light that is here in our office, and it was 3D printed, which was really cool. Seating, another thing that folks often talked about. Chairs were a really great example. This started as sort of okay, how do I design for additive manufacturing? How do I design for FGF? That was one of my biggest things that I've always talked to folks about. It's not as simple as scaling your tiny little, bamboo XYZ desktop printer model up that uses supports and things like that. When you scale up from a couple of inches to a couple of feet, your support structures change. It's not as easy as snapping off those little branching supports as it is when you do it, when you go from desktop to robotic. So designing for additive is so key. This chair was actually originally designed as a demonstration of that. How do you design functional products with additive manufacturing in mind? In the end, we actually decided we wanted to print it. So as you can see, this is the model here in the center, top, and then this is our digital twin sliced and toolpathed. And then the actual final print is there with our fun little lamp. So we were able to really talk about digital fabrication from start to finish. Our head of robotics, Sean Miller, was able to design this chair, slice this chair, print this chair, all within a week. And yes, you can actually sit in this thing. Folks are like, wait, is that strong enough? And yes, granted, it can hold, its weight is about 220 is where it maxes out, but you can actually sit in this. We sat down and had a holiday party a couple of weeks ago, and folks were chilling in this chair, which was pretty cool to see that, this started as an idea and ended up as a print in our 3D printed lounge. This is the one that I'm most proud of when I talk about hybrid manufacturing. This is something that I really talk to a lot about folks with. It's making functional prints, not necessarily printing the entire final object from scratch. Utilizing the 3D printing process, the FGF process for something other than just, I want to print a whole table. I want to make a whole table. Well, okay, how can we combine this and break this process down into something that's approachable for folks rather than, the concept of designing an entire table? Not a really easy thing to print when you think about it, but table legs were great. So my boss, Aaron, and I, we were able to put together a process where all of the parts except for the oak top there were 3D printed. We 3D printed these PETG legs, 3D printed these with polycore pellets, which was great. And we were able to use these to support our table, which is held together with 3D printed bow ties. And under the hood inside this, there's actually 3D printed dowels with carbon fiber pellets, as well as 3D printed biscuits, again from carbon fiber PETG pellets. PETG? Polypropylene, my apologies. Polypropylene pellets that really allows us to say, hey, you can build this whole thing that you need, except for the top. We could have printed it, but we decided to do some Vermont white oak. This really allowed us to show off the really cool things of what we can do with our printer, but also what we can do in terms of a hybrid manufacturing process. That's such one of the things that I talk to folks about. It's not as easy as you're going to go from model to print and there's not going to be any work done. That has to happen, which is so important for folks to understand as they start to adopt FGF. There's going to be some post-processing. Not everything is 100% perfect off the line. Not everything is printable right off the line. So being able to do this kind of project that allows us to show off what we can do while still utilizing both traditional manufacturing as well as FGF manufacturing. Um, and this sort of spawned a lot of ideas. We took this idea and kind of ran with it. We were like, okay, now we got this table. Can we print chairs for it? Like not just seats that I showed you before, seating, but chairs. So this is actually a model that we are working on internally at the moment. Um, the top model is the chair part, but the seat, as you can see in the bottom part, is actually going to be, again, made out of wood. So trying to illustrate to folks that FGF is a powerful tool that can be used as a multi-step manufacturing process. That is great for us to be able to talk about. You can use these prints in a functional way that allows you to make something that's both beautiful and useful. If you're familiar with the Scottish designer William Morris, he talks about beautiful and useful. And I think that's really what we can embrace as a community of FGF can be beautiful and useful. And talking a little bit about what we did this all on. So this is our spec sheet on Edith. We name all of our robot cells that we produce after, they're traditionally women's names, but they're usually old school names. So Edith with a Y. Edith is an ABB 4400 with a riser and a custom teach pendant. Edith is equipped with one of our massive dimension MDPE 10 industrials. It's got a hardened barrel, a hardened screw with a custom screw profile. And then we also utilize some of our accessories in there, which is the XL build surface, our MDMCU, which we'll talk about all of these in a moment, the feedstock agitator. And kind of give you a ballpark of the size of where Edith lives in our portfolio of what we do for deployments is it's about kind of the middle of where we live. We do a lot of smaller stuff with some of the robotic system cobots, but we also do larger stuff with the bigger cobots and some of the bigger industrial bots. But we also, like I said, do more and more with those gantry systems. So there's some cool stuff coming out in the next couple of weeks that I can't quite talk about, but stay tuned. There's some really interesting things that we've got coming out. And then sort of an overview about the materials we're using. We do a lot of process and proof of process with Edith. So we're oftentimes printing in PLA, PETG, and then about a quarter of the time it's other. Another is sort of my catch-all because there's a bit of TPU in there. There's a bit of polycarbon there. There's a little bit of glass-filled materials, or folks who want to do HDPE, which don't get me started on that. So we talk about that as well in our materials. So this is Edith. And then specifically the extruder. So the MDPE10 is our workhorse flagship product when it comes to what we're doing. This pellet extruder allows us the most versatility in terms of deployments as well as materials. So we get consistent, reliable throughput, hovers in right around 10 pounds an hour. With PLA at full pellet melt, we can really rock and roll at about 12 and a half pounds. But with this, we have the most versatility in terms of profiles for screws and profiles for extrusion and nozzles, which there's so many variables when it comes to FGF on this scale that it does get rather daunting for folks. Folks are like, do I need to hire a custom robotics engineer and designer for this? And I'm like, I mean, I wouldn't say no, but it's also, there's a learning curve. And once you've broken through the first sort of barrier of entry in that, you can do a lot with a little when it comes to FGF. And that's one of the things that we at Massive Dimension talk a lot about is what can you actually do with what you've got already. So the MD10 allows us to get this in front of a lot of customers and a lot of users, both in terms of academic users, research users, as well as industry users. So folks making tooling and molds. And one of the big things that we talk to folks a lot about is printing boats. Everybody is very interested in printing boats right now. So being able to provide a solution that can hit a lot of those use cases is super powerful for us as a team when we're trying to solve problems for our customers and our end users. And some of the accessory pieces, these are key for us. One of the things that I was mentioning to Michael from Re3D before is we're not a service bureau in that we do print on demand. We do the hardware selection and integration. So much of what we do is also beyond the extruder. There's so much more that when it comes to doing FGF printing on scale, and that's talking about pellet movement and heated beds and again, feedstock agitator, which when I first joined the company, I was like, what does this thing do? And then actually seeing it in action, you don't think about the concept of when pellets are moving fast under pressure, there's this buildup of static electricity that can happen. So pellets can become static bound in your movement systems. So there's so many nuances to FGF specifically that cause a manufacturing mindset change. When you're going to, I want to build this using this technology, there's a lot that has to be adopted and understood versus just standard 3D printing. So this was the feedstock agitator is kind of an interesting part of our portfolio because it's not something that most people will think about, but it has become so critical to so many of our deployments, which is great to see that folks are understanding what it's doing, and that we were able to overcome a very specific FGF problem. And that's kind of my overview. I'd love my sort of rule of thumb is I like to chat with folks about things. So I'd love to talk about more about your thoughts, questions you guys had. I talk about slicing if you want. I didn't go too much into that because slicing is a tough topic for a lot of folks. Slicing and tool pathing is a lot of content there that I feel like that deserves a chat into itself, but I'm happy to talk about any of that stuff as well.
Thanks, David. We'll go ahead and open it up to questions while the recording's still on. I think there were a couple people wanted to pick your.
All right. Thanks, David, for your presentation. I'm just thinking, when you print this whole shear, what resolution were you using for the printing on the I mean, I will say Z.
Yep.
as you go up, but yeah, what is the resolution you are using?
So it's variable. That's one of the dynamic things that can be controlled both with hardware and software selection. So our standard MD10 can go up to a 6 millimeter nozzle, which our rule of thumb is that we talk about creating a bead, sort of that resolution component, a bead that is half the max nozzle height. So it can go up to about 3 millimeters traditionally. So that is helpful when it comes to it, but it's nozzle selection as well as software selection. So the software can control some of the dynamic extrusions by controlling that motor and how fast things are moving through there. So that controls resolution. But I've had folks that want to use a 1 millimeter nozzle with a pellet extruder on the MD10, and they're hot swappable. You can easily change them out, and going down, obviously it doesn't have the same output in terms of speed and throughput of materials out, but you can get down to some pretty fine resolutions. We've had folks that use our MD PH2 with a 0.6 millimeter nozzle, which is a very familiar size for a lot of folks when it comes to desktop FDM.
Okay. I mean, the reason why I'm interested is that when we do a bigger print, we usually have the lifting. And do you have the same issue where at one end is lifting because it's very big?
In terms of warping?
Yeah, warping too, but at one end is lifting by the time you print on the other end. We usually have that kind of issues. And
So like layer adhesion.
Yes.
So
Yes.
yes, so we definitely have that. A lot of that comes through utilization of our software. So we don't design any of our software in house. We partner with right now we're partnered with two folks. We work with AI Build out of London. We work with Adaxis out of France. Both folks have ways when you load up a movement system profile, you load up a extruder profile as well as a materials profile, that there's a lot of thermal simulation that will happen that will tell you where you're at risk of delamination and that layer separation. So we're able to control a lot of that layer separation by managing and predictive thermal analysis. So if it's going to be too cold or too hot, the system will tell us, the software will tell us, and it will say, hey, you're in danger of, having a hot gooey mess over here, or it's going to be way too cold by the time you get over here to actually have layer adhesion. So that's how we manage it.
Good, excellent. So you're saying that these are commercial available software to
Yes.
use? Okay.
Yeah. Happy to connect anybody with those folks. There are both software folks are great teams. They are both at FormNext as we speak. So they're both got some really cool stuff going on in terms of I haven't had the chance to peruse through what they're releasing, but FormNext for those folks is a great way, a great opportunity for them to release new features in their software. So I'm excited to see what they're releasing here in FormNext. I saw a chat. Let's see. Dominic says, is the fourth heater on the MD10 extruder a nozzle heater? No. There's one hopper heater, like one feed heater that sort of preheats. There's 3 in the barrel. You can add a fourth heated nozzle, or a fourth in the barrel, but you can add a heated nozzle, extended nozzle, but it is not standard to our systems. It's not something that we always deploy. We always tell folks who are using a robotic movement system to use an extended nozzle in general, but it's not always a heated nozzle. So that's kind of the nice thing about the hot swappable nozzles and the screw profiles, because it allows us to really customize the extrusion rate and the residence time inside that barrel for the specific application. Like TPU needs to be short and quick. Nobody wants to have a lot of hot molten TPU in a barrel for a long time. So we need to move that quickly through the barrel versus other materials where you really need to load up the thermal capacity when you're like printing with PEEK. You really want to have those major heat zones that'll allow you to really keep the material at a high temperature. Can you talk about how you select and test your composite materials? Are you talking about composite materials in terms of carbon fiber and all of that, or are you talking about just filled materials in general? In general. So a lot of it has to do with specific finish output or strength output. So in the case of like that 3D printed lamp, the small desk lamp, I wanted a specific wood feel to that. So in that case, we picked our material both in terms of what we had available that's easy to compound. We used I think it was Total Corbian's LX175 compounded with walnut dust from a previous woodshop project that I had. So we made that material in-house that ended up getting turned into pellets and then printed with. So a lot of it starts with what is the finished product's desired out, like specs? Is it a texture? Is it a structural piece? Is it a tensile strength? And then we kind of go from there. So That is our first step. But then secondly, one of our big things that we really stress both on the Philibot side as well as the massive dimension side is there are alternatives to styrene-based plastics. There's ABS is a really lovely material for prints. It's not lovely for your body. Nobody wants to breathe in ABS fumes. So one of the things we talk about is what are our alternatives to ABS? What are our alternatives to ASA? What are our alternatives to polystyrene? So how can we utilize materials that we build or custom blend to achieve the same results, but are not so bad for us and the environment?
I have a follow-up question about your discussion earlier about the thermal simulation software and stuff. I also do quite a bit of FGF printing here at Re3D with our pellet machine. And I usually print with a 1.75 millimeter nozzle. And obviously a big challenge with printing with larger nozzles is just the thermal mass of the beads and the fact that it's so hard to cool and give it enough time and just create the right setting for it to work very well. So if you run a thermal simulation and it does tell you that it's going to make a hot mess in one area, how do you mitigate that? Do you change it from the design side, or do you just slow it down a lot, or what's your approach?
It is a multi-factor approach. That is a great question. It is a multi-factor approach. So we can change from the design side. That is one way to do it. One way to do it is with the slicing, and say you can do the dynamic extrusion where you're saying, I'm going to slow down or speed up. And that can be one of two things, because the goal is, again, to make sure that your layers are consistent enough to build the geometry of your part. So if you're going to have fast printing in one section and then slow down, that needs to be mitigated with extruding faster. So that oftentimes is turning into a very delicate dance of a multiple layers of things. The other things that we do, we have a heated bed. So we utilize heated beds. We don't have an enclosure system. It's hard to do that with a robot. Robot enclosure, tough. So we also utilize heated beds. We also use stationary mounted tripod heaters to keep the part warm enough. We use a lot of laser thermometers to test as we're printing. Printing on a large format scale is not necessarily a set it and forget it like you would with a bamboo printer. So we're doing a lot more monitoring of it. And then there's somebody, they're working on something else at the same time, but they're monitoring that print. And if they start to see some things go and they test it and they're like, oh, I got to heat this up or cool it down. That's one way. And then in addition, we also have an optional accessory for our extruders. It's a print cooling fan. That gets mounted on the extruder itself. And the way it's set up is that it'll cool the part after it's extruded. Or it can also be set up to cool, depending on how you have it directed, cool before the extruder passes over it. You can kind of set it up on the back side, which is traditionally how we have it. You can set it up on the front side or one of the sides. So depending on where the fan is and how it's directed, you can kind of customize it to your particular tool path.
I see. That's really interesting. And just one quick extra question. Have you worked with other types of materials that warp a little bit more? It obviously shows up a lot more in larger scales. I remember you just said HDP, don't even talk about that.
Polyethylene in general, everybody has an excess source, particularly on the Philibot side. Everybody has this source of polyethylene, whether it's post-consumer waste, post-consumer waste, injection molding waste, something. Everybody has polyethylene. LDPE is a pain in the butt to print with. That's why you don't see a lot of commercial filaments out there with it. HDPE is manageable, but then again, it's a lot more of managing your print settings and your thermal settings, your heated beds, your stationary heaters, your print cooling fans, because warping does happen. And one of the things that we've also done, it kind of is a little janky sometimes, but OSB and screws on a weld table. You make a nice big wide brim, and you are printing straight onto like some OSB, and you're screwing that brim down.
Yeah.
That's one of the things that we've done that has, when we're developing a process for a customer who wants to print something big and weird in a weird material, like polycarb is a pain in the butt. Without an enclosure. So that is one of the things. And then we oftentimes push folks in that case to utilize a low fiber filled material. So something with a lower fiber content, so it's not as expensive or added weight, but something the fiber content will help to sort of break up the crystalline nature of polyethylene and allow you to manage that warping and twisting better.
Got it. Thank you.
Yes. And building off what Mike Parker here has asked, as well as talking about polyethylene, HDPE. A lot of boats, folks are talking about HDPE when it comes to boats, fiber-filled HDPE, as well as I've had some folks who are looking at more like a glass fiber-filled nylon. Because again, you want to make sure that you're getting something that has really good layer adhesion, building off the earlier question, because when you're building a boat, you want it to be watertight. And with that, you're able to you select materials that are good for that, but you also want strength and lightness. So HDPE is sort of the material that we select when we're talking about boats. But boats are a tough boats are a tough thing because they're large. And again, folks, there's a conversation. We talked a lot of conversations about printing a boat. Folks want to print one, they want to have a setup, they want to press play, they want to walk away, and there's a boat in 2 days on their, on their build surface. It's not like that. The way we do things like that is print in parts. The way they're a naughty word at the office, but Seed and Caracol do it as well. They're printing boats in parts and doing polymer welding out after the fact and fusing parts together in order to create something that is structurally sound and familiar, but is also additively manufactured.
Great, thanks.
Have you had success with PP at scale? Yes and no. Polypropylene is right at that sort of, I wish we had, I'll say this, I wish we had better success with polypropylene. I like polypropylene myself as a material on both sides of our business. It's easily recyclable. It's hydrophobic, which is great. It is a waste stream plastic that we can divert downstream from post-consumer or commercial ways. A project I have in works with a school district and a desktop 3D printing company, which I can't say yet because we haven't finalized all the details, but we're talking about utilizing our Philibot systems to basically do that, to take polypropylene, particularly yogurt containers, shred them, turn them back into usable feedstock for both filament as well as pellets. So to answer your question, yes and no. Polypropylene at scale is tough. Polycarb at scale is really tough. How do you mitigate the inherent stringiness nature of pellet printers? Great question. Travel moves are the devil when it comes to pellet-based printers. There's a lot of folks out there that will tell you that they've mastered travel moves without stringing. but I have yet to see one in a practical application really work particularly well. We do, one of the folks out there, there's a Canadian producer that talks about a pneumatically actuated screw pin that will plug the nozzle. Does not work. Because you got to remember, you're building up a lot of pressure inside this extrusion barrel, and then you're suddenly sealing it off, and that pressure's got to go somewhere. And oftentimes it goes back up into the hopper, and that's a hot mess. So dealing with that is a bunch of strategies for us, particularly. It's strategies of slicing, strategies of designing the part, strategies of we get the added advantages of a 6-axis printer versus a 3-axis printer. We also have the added advantages of, in our warehouse and our R&D shop, we have a heated rotating tilt table from ABB, which is beautiful when it comes to helping mitigate the stringing and travel moves. So it's really our first go-to strategy is slice to avoid travel moves when possible. After that, it's that's where that conversation with the customer comes and says, post-processing. We're going to talk about post-processing. I had a customer who we did a proof of concept print for. They wanted to make outdoor furniture, and in order to do so, they were a designer, and they made some outdoor furniture models, and they said, "Can you print these?" And they said, "Yes." We put it through the slicer, and it was a hot mess. The slicers and tool pathing shows us in very great detail where there's most likely going to be stringing. So we talked about post-processing with that customer. So that's one of the things that we talk about when it comes to managing stringy nature of materials. And then it's also material selection. Some materials are stringier than others. So, which leads into what's my favorite material for large-scale projects. PETG. When in doubt, PETG. We utilize Polymaker Polycore pellets for a lot of our stuff. We are an authorized distributor reseller for Polymaker, particularly for their Polycore pellets. So we utilize PETG 1000. The chair was made out of PETG 1000 that I showed you. The chair legs were made, the table legs were made out of PETG 1000. There is also a great, there's also glass-filled versions of that material, which are great. So if you haven't printed with those, I mean, we all know, I think that AirTech pellets are pretty dang beautiful when it comes to printing oftentimes, but they're pricey, and sometimes they don't have the particular blends or particular materials that we need to utilize for customers. So we really like the Polymaker Polycore stuff, and I like PETG just as a material. It's something that I can talk to customers about. They, guaranteed they have some PETG in their fridge right now. They've got a clamshell of some lettuce, probably made out of PETG, so they can understand conceptually what they're printing with, which is helpful. The more you can relate a new FGF user to something that they have experience with, the easier it is for them to adopt FGF in their manufacturing processes. Doug asks, can you tell us more about the printing surfaces you have used? You mentioned screwing a brim down to MDF, but you also sell a heated aluminum bed. What do you like to do for large FGF printing? Again, depends on the application. We actually have three go-to strategies for built surfaces. Our number one strategy is our 3.5 by 5 foot heated aluminum bed. The aluminum beds get up to 130 degrees Celsius, which is great. It really allows us to manage that thermals for that, but we have a weld table, which is helpful for certain applications. And then also the welding table is great when you're using MDF, because you can slap MDF or OSB on top of that, clamp it into place, cut it to the size of the weld table, and then it's already got holes in it. So you can line your you can line your bolt holes up with your MDF and your weld table. So traditionally, we like to go for an aluminum bed. That's our go-to, our heated aluminum beds, which I have very recently become intimately acquainted with how we manufacture those things. Not a fun process. If you've ever wanted to do the most tedious task in your life, build a 3 foot by 5 foot aluminum bed and do some metal sanding on that thing to get that thing spick and span, not fun. But that's what we like to do when it comes to FGF printing. That's sort of our go-tos. How do you attach the heating element to your aluminum heated bed? Is it mechanically held or with an adhesive? Great question. They are mechanically held. It's a heated blanket underneath. I don't. You can probably, if you take a peek at our website, it's a thick aluminum bed with a bit of a skirt, and underneath that there is a heating element blanket that heats it all up. They are rather powerful. They can pull 7,500 watts. Which when folks want to put 4 of those together, that's a lot of power to put together. But I have definitely provisioned systems and scoped out systems for folks who are like, I need a 10 foot by 5 foot heated build plate. And I'm like, do you have the power required for that? So, but yeah, it's not an adhesive. It is a mechanically held in place sort of thermal blanket with heaters built into it. Cool. If any, is the agitator mounted to the extruder? The feedstock agitator is actually off to the side, and there's a tube that connects into the extruder right by the hopper inlet, because that's where we find the most static buildup of pellets as it comes into the barrel from the hopper, and it blasts it, and it's actually at an angle in the thing, so it pops it up, so it'll fall back down. Because particularly with when you're doing inline colorant with your PETG or something like that, that's where we found some of the most static is built up. When you want to use colorant inline with your material, with your neutral colored pellets, that's where we're getting the most static. So it's a surprisingly helpful little device. Like I said, never would have thought of it myself as somebody who's 3D printed with filament before coming to the FGF world. But I see the impact of that thing every day when I'm at the office.
David, thank you for answering all of these questions. I know it's really exciting for us to learn from your experience. We'll go ahead and turn the recording off. I think we have a couple minutes if anyone wanted to ask any offline or to the other people in attendance.